All right, for 6.2, we are going to talk about the law of cosines. And so, very similarly to the law of sines, we're going to be working with triangles, which are not necessarily right triangles, right? Otherwise, we would use Pythagorean theorem and the definitions for sine, cosine, and tangent. But that's not the case here or with the previous section. So this is going to help us solve triangles which were given two sides and then the included angle, or an Sas triangle, or those which were given all three sides but not an angle, right? So for those, we have an example here. So Sas means side, angle, side. We are given the side, in between angle, and then another side. Or we will be given the three sides of the triangle but not the inner angles. Okay, so here's the definitions for the formulas. So the first one is side squared is equals to the length of B squared plus the length of C squared minus 2 times the length B, length C, times cosine of angle A. So you see this relationship all throughout the three different formulas, that the side squared that you have on the left side of the equal symbol is the same that you have here inside of the cosine function, right? So b squared, and at the very end you have cosine of b, right? So we see this pattern all throughout, and as usual, a, b, and c are going to be the measures of the angles of the triangle, and then a, b, and c are the length of the opposite angle of the sides opposite of these angles, right? So those are the definitions for the formulas. Now let's talk about how we get to those formulas. So we are looking at a figure like this, right? We have an acute triangle like the ones we've been working perhaps in the previous unit, or the previous section, I mean, right? This is a triangle which could have three acute angles, or two acute and one oblique, right? So angle A starts at 0, 0. Angle B is at the point C, 0, right? There is some C length. And angle C is at some random XY length, okay? So this is what we have, right? The height is Y, and this length is X. This is B, and this is A. So that's the figure we have so far, right? Now, let's go ahead and do a couple definitions before we get going. So let's, for example, define cosine of A. And even before I do that, let's not forget our SOHCAHTOA, right? So cosine of A is equals to the adjacent over the hypotenuse, right? So it would be the length of X over the hypotenuse B, okay? Then sine of A is going to be opposite, which is Y, over the hypotenuse, okay? So if we solve for X and Y, we get the following. x is equals to b cosine of a, and then y is equals to b times sine of a. Okay, so if we want to figure out, for example, the length of a, then we're going to use distance formula. So the length of side A, we'll use distance formula, and the distance formula will be from this point here to that point there. All right, so A is equals to the square root of the difference in x's, so it's going to be x minus c squared plus the difference in the y's, right? So y minus 0 squared. A is equal to, or if we get rid of the radical, it would be a squared is equal to x minus c squared plus y squared. Okay, and if you remember from above, here's x, here's y, but here's the definition, or some definition for x and y. So we can plug in those values, and we have b minus cosine of a minus c squared, although probably it would be easier for me to FOIL this before. So let's go ahead and FOIL this, because it's going to get really complicated if I go ahead and substitute the value of x beforehand. So if I do that, a squared is equals to x squared minus 2xc, right? Because x times c will be negative xc, and negative c times x will be the same thing, plus c squared plus y squared. Now I'm going to leave a little room because I'm going to plug in the value for x and y. Okay, so this is what we have now. We brought in the value for x, which is b cosine a, but since we squared it, we have to square everything inside. So that means b squared times cosine square of a, and then here we have negative 2b cosine of a times c plus c squared plus b squared times sine squared of a. Notice that we have b squared here, b squared there. So let's try to bring those closer to each other. So b squared cosine square of a plus b squared sine square of a minus 2bc cosine of a plus c squared. And if you factor out the b squared, you have cosine square of a plus sine square of A minus 2bc cosine of A plus c squared. And if you remember from Pythagorean identities, you know that cosine square plus sine square of the same argument equals 1. So a squared is equal to b squared plus c squared minus 2bc cosine of A. So this is how we find, at the very least, the first definition. Okay. A squared is equals to b squared plus c squared minus 2bc times cosine of A. And so that's one of them. And if you were to look for the length of B or the length of C, you're going to find that it is the same process, right? You're going to do distance formula between the other 2 points, plug in the corresponding values, reorganize, and then you will be able to find the other definition. Okay? So, how are you supposed to solve an SAS triangle? Say you're given a triangle with 2 sides and the angle between them. So, first thing you're going to do is use the law of cosines to find the side opposite to the given angle, right? You're going to find the opposite by plugging in what you're already given. Seems simple enough, right? Then you're going to use the law of sines to find the angle opposite of the shorter of the two given, because that's always going to be an acute angle. Then you at least can expect the angle to be small. Then you're left with finding the third angle, and you're going to do that by subtracting the measure from the given angle and the one you found previously from 180, right? Because all three angles have to add up to 180. All right, so let's do an example solving an SAS triangle. Okay, so you're given A to be 60 degrees. You're given B to be 20 units of length, and then C to be 30 units of length. So what you want to do is round to the nearest tenth, and that is the length, right, of side A. And whatever angle you find, round it to the nearest degree. So first thing we want to do is find A. So A squared is equals to B squared plus C squared minus 2BC cosine of A. That's the definition that we're going to use. So, do I know everything for this problem? Yeah, most likely. So, do I know B? Yes, it's 20. C is 30. So all I have to do is plug in the values in their corresponding place. Next, all we have to do is simplify a little. So this is going to be 400, this is 900, then 40 times 30 is 1200, and then cosine of 60 is 1/2, right? So then if we put all this together, we get 40, or 400 plus 900 is going to be 1300. And 1300 minus half of 1200, which is 600, goes down to 700. But then keep in mind that this is all equals to a squared. Once I find a, I'm going to get plus or minus the square root of 700. And I'm going to take the positive value. And this is going to be roughly 26.5. So once I have that, all I have to do is continue with step 2, which is going to be using the law of sines to figure out one of the other angles, right? So we know a, so we're going to do that. A is equals to, well, a over sine of a is equals to b over sine of b, right? So 26.5 divided by sine of 60 is the same thing as, do I know little b? Little b is 20. I don't know the value of b, so we're going to have to figure that out. Multiply both sides by sine of b, and so sine of b is equals to 20 times sine of 60 divided by 26.5, right? Which comes out to be 0.6547, and then we do sine inverse of both sides and roughly get 41, and this is 41 degrees, right? So all that we have left to do is figure out angle C, and it's the same thing as 180 minus 41 minus 60, right? Which comes out to be 79 degrees. Okay, so step 1, 2, 3 will be how we should do this type of problems. Okay. All right, next, how to solve a Sss triangle, right? When you're given only the sides of any triangle, well, first thing to do is to use the law of cosines to find an angle opposite to the longest side. All right, so we want to look for the longest side first. Then we want to use the law of sines to find the other two remaining acute angles. And last, we're going to just subtract from 180 the two angles that we found, right? That's going to give us the last angle. So, given this information, A is 6, B is 9, and C is 4, let's try to find the remaining angles or the remaining information of this triangle. Okay, round the angle measures to the nearest degree. So A is 6, B is 9, and C is 4. So Step 1, find, what do we say? Use the law of cosines to find the angle opposite to the longest side. So we're looking for B, right? We're looking for angle B. So 9 squared equals to 6 squared plus 4 squared minus 2, 4, 6. Let me write the definition below so you know what I'm talking about. Okay, so I'm doing this, right? B squared equals to a squared plus c squared minus 2ac cosine of b, right? And then here, cosine of b. So I'm solving for b, pretty much, right? This is what I'm going to try to get by itself. Well, if you really want to show your work, then this is the way to do it. I moved everything to the left and then divided by the product of 2, 4, and 6, which leaves me with cosine of b. And then I would do cosine inverse of 9 squared minus 6 squared minus 4 squared over negative 2, 4, 6. This is all equals to angle B. Taking a step back to look at this, cosine B equals to negative 29 over 48. We see that that's a negative angle, right? So that tells us that angle B is going to be an obtuse angle, right? It's going to be a larger than 90 degrees. So if we just make it positive and plug it in the calculator, we're going to get that B is equals to 53 degrees, roughly. It's not exactly 53, but if you approximate, it's what we get, okay? And we can find that B is equals to 180 minus 53 comes out to be 127 degrees. So even up here though, you are still going to get 127, but this right here is more of a analytical explanation to look at why it comes out to be 127 and so on. So B is 127, okay? So now that we have one angle, we can then move on to step 2 and just work our way to find the other angle inside. So we'll do B over sine of B equals 2, and at this point we can choose whichever we want to find. So we'll go and find angle A, and we have B equals to 9. Angle B roughly 127. A is 6. Sine of A. And we're going to solve for sine. So sine of A is equals to 6 times sine of 127 divided by 9, and As always, try to make sure that your calculator is in degrees so that you don't try to figure out something that's in radians. Well, your calculator is going to think something is in radians if it's not in the right mode. So you will get the wrong answer if you don't make sure your calculator is in degrees. And once we do this, we come out to get 32 degrees. And so the last step is to figure out C. And it is the same thing as 180 minus 127 minus 32 degrees. And it comes out to be 21 degrees. So we have solved the triangle pretty much, right? We have all the three lengths and all of the three angles inside of it, okay? And that leaves us with the end of unit 6.2, which is solving triangles using the law of cosines.